Okay, hello people. All right, so we're doing this question. This is from the textbook, old textbook. Oops. Okay, you know what? I'll just move this up. So there's your question. Okay, page 96, question number 10 in the old text. All right, so the first thing that we're going to do is just write down our FBDs. So there's your FG, and this mass right here was given to be 5.12. So this is 5.12 kg, and this one is 3.22 kg. Okay, so mass 1, this we're going to call 1, this we're going to call 2, is 5.12 kg, and mass 2 is 3.22 kg. So there's your FG2, there is your FT, there is your FT here as well. FN coming out this way, FG going towards the center of the earth, FGY, and that is opposing your FN, and of course your FGX, which is the same angle as, or I should say the same, it's parallel to your surface, and this angle right here of course is 35.7 degrees. Okay, so when we're solving this question, we are looking at systems of equations, and we are going to try to solve it using first looking at which of these two masses is causing my motion. So what do you think? This mass is 5.12 kilograms. This is 3.22. Which of those two masses do you think is causing the motion? Yes. You think M1 is pulling it down? Yeah, what do you think there? You think M2 is pulling it down? Okay, I actually don't know which of those two masses is pulling it down. Yes. Yeah, the angle is steeper, but this one is no angle, so there is nothing that is impeding his motion towards the center of the earth. There is nothing here. By the way, this surface right here is a frictionless pulley. Yes. Yeah. Less acceleration in some way. Yeah, you could say that. Yeah. Oh, which way does it say? Oh, it tells you. That's correct. Thank you very much. It does. The textbook does tell you that this is going down this way. Thank you. Yeah, but I mean, if you didn't know, if the textbook didn't tell you, then you would have to figure out which of those two masses. And the good thing is, no matter which way you went, you would give you either a positive answer or a negative answer. So you would have figured it out that, oh, it's going in the wrong direction. Okay? All right, so it's going this way, so let's go figure it out. So first thing I'm going to do is I'm going to say FG2 minus FT, which equals to mass 2 times acceleration. And this one right here, well, what's pulling me upward? Yeah? Yeah? That's correct, yes. Yeah, the book is telling us that mass 2 is going down. Yes. Okay. All right, no problem. And in this situation, your FT2 is going to be pulling it upward. I should say FT. Okay. Minus your FGX, which is pulling you down that way. So minus FGX, which equals to mass 1 times acceleration. Of course, we're going to add the 2. This and this cancel out. You're left with FG2 minus FGX, which equals to acceleration times mass 2 plus acceleration times mass 1. Okay. So let's go solve it. So your mass 2 is 3.22 times 9.8 minus FGX, of course, here is mass 1, which is 5.12 times 9.8 times the sine of 35.7 divided by the two masses here, which is 5.12 plus 3.22, which gives you acceleration. What gives you what's your acceleration? By the way, we were trying to find the acceleration of the system and the Ft in the string. What do you get for your acceleration? 0.27 meters per second squared. Mm-hmm. Mm-hmm. Why did I write FGX? Where? This one right here. Well, look at it. This is mass 2. Yeah, this is mass 1. This is mass 2. Yeah, this is mass 2. This is mass 1. Correct? All right. Anyways, let's continue. So this right here is your Ft minus Fgx, which equals to mass 1 times acceleration. So I'm going to use this to figure out my tension. And let's erase some parts of it. Okay. Okay, so Ft minus Fgx, which equals to mass 1 times acceleration. So your Ft equals to mass 1 times acceleration plus Fgx. Okay, mass 1 was 5.12 times 0.27 plus this one right here was again 5.12 times 9.8 times the sine of 35.7. And what do you get for your tension? .7 newtons. Now, of course, as we know, acceleration depending on which object we're looking at, either the acceleration was going down or it was going up this way. So this would have been counterclockwise, I guess you could say. Okay, same thing with your tension. Depending on which direction you were at, you would have the tension going appropriately. Are we okay with this? Now, this we've done with a frictionless surface. Your friction was non-existent. Cool? Any questions? Yes? Or you just say either it's clockwise or counterclockwise or so on and so forth. Yeah. I know. Yeah. It'd be nice. Okay. Okay, let's erase this. Are we good with this? Can I erase it? Yes? All right. So the next question that we're going to do is also from Nelson Physics again, the old textbook. And the question is as follows. This is page... this is page 90, old text. Okay, sample problem number 2. And the question is as follows. What you have are two sleds connected like so. Okay. And a few things are given to us. So what they gave was that this tension right here, so we've got two strings, Ft1 right here, and this is Ft2. Okay, now remember in the first question, that pulley question, our tension was conserved. And the reason it was conserved because you had one string that it was pulling the whole system. Here you've got two different strings. This tension is given to you. So Ft1 is given to you as 29 newtons. Okay. This is mass A, and mass A has been given to you as 6.7 kg. And this is mass B, and this has been given to you as 5.6 kg. So mass A, 6.7 kilograms, mass B, 5.6 kilograms. They also gave you a few other things. Of course, you've got your Fn, you've got your Fg, Fn, Fg, okay, Ft1, and then they gave you this right here, which was Fka, and this is Ft2 and Fkb. And Fka was given to you as 9 newtons, and Fkb was given to you as 8 newtons. Okay. Now, when we're looking at this question, we need to again solve for two things: the acceleration of the system and the tension in the second string. This tension is given to us already. We want to find out this tension right here. So when we're looking at this question, again, it's a system equation. Now remember that this tension in that string is caused by which mass? The one behind it. This tension in this string, the first string, what is that caused by? By both my masses. Both my masses cause this tension. However, the tension in this string is only caused by this mass. Now, if this string did not exist, it wouldn't really change how much tension I pull this with. Yes? Well, it tells you Ft2 right here. Okay, this is given to us 29 newtons. Okay, so what we're going to do is that's how we're going to solve for it. Let's start with it. We're going to say Ft1, since this is pulling my whole object together. My whole object forward is being moved by Ft1, minus Fka minus Fkb. Okay, which equals to mass A plus mass B times acceleration. Fka and Fkb. And you're like, what about this tension? Well, this tension does not really affect our equation in any way, shape, or form. It does not affect this acceleration. It's as if this string does not exist. It's as if both of the masses were together. Okay, so we have given this right here, so that's 29 newtons minus 90 newtons minus 80 newtons divided by this mass that's given to us right already, which is 6.7 kg plus 5.6 kg, and this gives you an acceleration. What acceleration do you get? 0.97 meters per second squared forward. Okay, are we okay with that? Now, to get this tension, we have to make an equation just for that little mass right there. And to do that, we'll just do the following. We're going to say Ft2, which is causing my forward motion, minus Fkb, which equals to mass B times acceleration. Does that make sense? Right? So what you're going to do is solve for it then. Ft2 we don't know, which equals to mass 2, which is 5.6 times 0.97 plus 8 newtons. What do you get for your Ft2? 13.5 newtons forward. Yep. This equation, the bottom equation, I'm looking at the equation, I'm saying, well, what is causing my motion? My motion is caused by Ft2. That's pulling it forward. What's opposing Ft2? Well, the Fkb is opposing it, which equals to your ma. Right? So this is literally F net equals to ma, correct? And this right here, this whole thing is also F net equals to ma.